All right, hello everyone. Welcome to our 1-year anniversary. We started in this room a year ago at the Pebble Developer Retreat 2014, and we've been doing them for a year now, and now they've spread across the world, and we have 24 groups. It's awesome. It's really fun. If you are in an area that is not San Francisco and you'd love to bring a little piece of either the retreat or these meetups home, contact me. I'm always happy to start new cool things in new regions and expand that number from 24 to I don't know what next year. So just to tell you a little bit about the schedule, Heiko's going to come up and talk for a half an hour about Pebble Time Round, developing and also designing in a little way. We have 3 smaller talks. One of them is going to be by Nate Stockham about Wearable Psychiatry. And the second one is going to be Shuyang. Did I say it right? And she's from Seed Studio, going to talk about a new connector module that they're making for smartstraps, which is really cool. And then we're going to have Mathew Reiss come and talk about the Simple Dithering Library that he created to go from 64 colors on the Pebble to 343-ish. It's really cool. So after that, we're going to have some community demos. So I have a list of a couple people who have already volunteered to come up and share what they've been working on either today or in the past. And then after that, I'll have sort of an open forum if you want to come up and share anything that you've been working on or have made in the past that you want to share with the audience. That would be awesome. And we are out of here at 9:30. So without further ado, Heiko, developing for round.
Thanks, Beth. Thomas asked me to apologize up front to those that watched my presentation early this morning because I will repeat a lot of my stuff. But due to popular request, I actually kept the animations, so you can see them once more, if nothing else. And prepare for even more interesting questions after that. I'm happy to answer any question with respect to Pebble Time Round. Okay, so I'm Heiko. I am part of, so for the last year, actually, I was in the team that developed all the graphics, UI, and animations for the original the Pebble Time and Pebble Time Steel. And once we shipped that, we switched over to Pebble Time Round, where we had different challenges such as text flow or drawing round elements in the first place. But I'm also, and I cannot stress that enough, part of our internal WTF engineering group consisting of Brett, Catherine, and me, and everything we ship as an API goes over our table, and most of the time we can agree on something, and then we have something new to play with, such as the new SDK 3.6. So you can download that already, and just this morning, actually last night, we provided a new version of the developer preview. It's now 6. And the API calls you see in this SDK work perfectly the same on both Basalt, which is our development, our runtime platform, as we call it. It's basically right now the watches Pebble Time and Pebble Time Steel, as well as Chalk, which is the Pebble Time Round. So every API call I talked about today is available on these 2. And then I just want to mention that briefly, later this year, every single API call is available on all 3 platforms. So these API calls are also available on your original Pebble and original Pebble Steel. Cool. So when it comes to Pebble Time Round, nothing really changed much. It's the same MCU you are familiar with Pebble Time or Pebble Time Steel, same amount of RAM, and same display, basically. It's really also the same color perception on it. It has a smart strap connector and a mic, so you can use everything. The only real difference is the display. It's round. So we go from our 144 to 168 to a round display. And if you put a square around that circle, that would measure 180 by 180 pixels. That's the core difference between the 2, and that actually creates a few challenges for us as a developer. Except for that, much of the SDK is actually the same. You have the emulator also on Chalk. Just pass the argument Chalk to the SDK, or if you're running Cloud Pebble, just use the Chalk emulator over there. It just works the very same way. All the graphics you're familiar with, like vector graphics, PNG support, all the colors you have, everything you have just works on the same way on both platforms. Also, timeline. just pass your data to our REST backend to submit actions, to submit anything you want to inform the user about, and it just magically appears on both, and we take care of the rendering. You just deliver the content. Action menu, a recent addition to our SDK where you can drill down to different sets of actions. All that exists. There was never a way to control the layout anyway. We just render it differently on Round and it works. And then the smartstrap connector is there, of course, same pin layout, everything the same. And with the 3.6 SDK for the first time, developers have access to voice. So actually dictation service, how we call it internally. You can use the Pebble to dictate text and do something with it. And that perfectly works on both Gazelle and Chalk. So basically all the stuff you already know works on both platforms. I want to talk about something that's different when it comes to text on a Round display. And then second, a few new drawing routines that are specifically designed to cope with the problem of roundness in general. And then the third one is a small overview or a brief overview of what is different when it comes to UI, our existing components. Cool, so let's start with text. We started off with a very naive and simple approach to rendering text, and that's basically just treat the Round display as if it was a rectangle, but make it a bit smaller. So if you scroll text, you would basically just scroll text there, but on a rectangle that is a bit more narrow. So think of it as a long string of text that goes from the top to the very bottom, and all the text just floats there as a rectangle. But because of the shape of the display, you actually have some limitations. There's actually not the full width of the display you can safely use. You have to decide which rectangle you want to use to render text. You can decide to use a very wide rectangle, but then it's not as tall anymore. That may or may not be useful for, say, menus. Or you can make it more narrow and then it can be taller, but in every line you can only fit maybe 2 characters. So somewhere in between there would be a good ratio. But it also means that for whatever rectangle you decide to go with, you can never scroll or page by a wider or taller amount than greater amount than the box is actually tall. So here, for example, you lose the speed of scrolling and everything. Basically, you see not enough. Let's zoom in here. I decided for this example to go with 130 by 120, but what we are really aiming for is to use the full size of the display. We have, compared to our previous screen, roughly 7% more pixels on the screen. Why couldn't we use it? Why should we limit ourselves to a rectangle that's even smaller than the display we had on the rectangular version of Pebble? If we want to do that, and if we want to use the full screen, we actually have the problem. Designers call that text flow. Flow the text according to a shape. Here, it's the shape of the screen. How can we not just break and start over at the same x coordinate? How can we actually follow the curve of the screen? That's quite challenging. You, as a developer, when you develop for Pebble Time Round, you don't really have to learn anything new. You could try to accomplish what we will see here with all the APIs you already know. So on Pebble Time Round, on the Chalk platform, you actually get a window that is just a rectangle, more specifically a square, that has a size of 180 by 180. Okay, fair enough. But what we actually do is we don't render a rectangle, of course, or actually on the physical device you don't see that. Instead, you see a circle. The logical coordinate space, although, the logical coordinate 0, 0 is outside of that screen. So 0, 0 is not even on the screen. But if you go from 0, 0 to the right to 90, 0, which is 12 o'clock basically on the screen, that would be visible. Make sense? Cool. So now if we have that window, you already know the APIs. You could create a text layer that is as large as the screen, set the text, the background color maybe, and you have the result you see here. On the rectangle, that makes sense, but actually on the round display, you see that all the letters are flipped. The next step would be maybe to horizontally center the text, which looks somewhat better around the equator, so vertically centered on the screen. But the further you go up or down on the screen, the less you can actually see. And remember, we don't really want to make the box more narrow. So we introduced a super convenient one-shot API call to make that very easily approachable, and that is text layer enabled screen, text flow, and paging, which does all the magic for you. So that API call exists on both Basalt and Chalk, and it will just enable text flow according to the screen. And it also does some magic when it comes to scrolling. So on Basalt, you might have seen on a scroll layer that whenever you scroll, sometimes certain lines were halfway visible because they were just falling between the two pages of the scroll layer. Once you use this call, we also take care of that and add extra spacing between those lines in question. And that's basically it. We had it earlier today at the dev retreat where we were hacking on different apps. This call, TextFlow works, boom, that's it. When we were experimenting with TextFlow, we actually learned that scrolling doesn't work that well with TextFlow. And that is just because when you move text gradually over the screen, you reflow the text constantly, and it could even mean that if you move up the text, some words actually move down at the same time because the previous word doesn't fully fit on that line. What we recommend is to use paging in conjunction with the text flow. That doesn't even happen if you use the call I was presenting on the previous slide. But what you still would see is that circles of text would slowly move over the screen, and we just want to see that. Instead, use paging. Cool. So that's something you should consider when you deal with text. For simple layouts, such as I just have a watch face that shows something on the center of the screen, you are totally fine with just horizontally center the text inside of a rectangle that is vertically centered. If it's just one line and just a few words, you don't have to care that much. But when it comes to body text, long text that goes over multiple screens, that might be interesting. Next up is drawing. So drawing is a bit challenging because of our coordinate system and angles and insets and everything. And I make a short version of what I was talking about this morning. Actually, I will just present you the results. If you want to do complex things, such as here where we draw sectors, or here where we need to draw certain annuli actually, Latin-wise, to overdraw the hands, or even here when you want to calculate where circles lay around the screen, you might want to do something with sine and cosine. That is not everybody's favorite piece of math. And then also, you want to have that crisp and anti-alias. Our new drawing routines take care of all of that. So we have two new calls. One is fill radial, and the other one is draw arc. And they have a whole set of different arguments. And instead of just talking about that, I want to show that in action. So you describe a circle not by its center point and the radius, but instead by the bounding box. You provide a rectangle. That could be, for example, your window bounding box. So when you create your window or something, you have this give me your bounds, or when you have an update prop, you say layer get bounds. Just use that. If you use it, the circle will fill the full screen or your full layer. So you use that rectangle, and then a mode, an inset, and a from and a start angle and an end angle. And in this example, I'm actually changing the end angle to show what happens. With the given parameters here, like the inset, for example, which says how wide the ring should be, and the rectangle, which describes the outer radius, you can now create an annulus that has a different start and end angle, as you can see. You could also vary the inset. So here we are drawing nothing. If you increase the inset, which means how far from the outside should I go to the interior, up to infinity, which means that we degrade to drawing a sector. If you combine that with the start and end angle at the right values, you can draw a circle. So that would mean you start at 0, you end at 360. The inset would be very large. Here it's 62, which is half of the width of the rectangle, and you have a circle. Together with our draw arc, you can have very interesting effects. So drawing in our API was always drawing the outline of a rectangle, drawing the outline of a circle, drawing just a stroke following a line. And you can have control over the stroke when it comes to the stroke width and the stroke color. And here I'm actually changing the stroke width. And the way I'm describing the arc is absolutely the same we had seen before. So we pass in the rectangle, and we have a start and an end angle. And you can combine all this to achieve these effects. when you use, when you calculate these angles, I had another conversation earlier today, oh, how do I do that and this? You can actually go all the way 3,000 times around, multiple times around the circle actually without any problems, positively and negatively. But the start angle comes before the end angle. When it comes to angles, actually, we chose the system in a way where 0 is actually at the top, 12 o'clock, and we go clockwise. That makes it very easy for you as a watch face developer to derive actually angles. You can use the minutes of an hour or the hours themselves to easily derive what the angle would be. And then we have another argument here just after the rect. All the rectangles I was presenting were actually special cases, squares. What happens if your rectangle is not a square but a rectangle? Well, this argument actually decides. We have two modes of an enum right now, and one is G oval scale mode fit circle, and it makes sure that a circle perfectly fits into a rectangle. It fully fits out the rectangle. And we have the counter version of that, which is filled circle. It makes sure that the rectangle is fully filled with that circle, where the circle is always in the middle of the rectangle. So this is all for drawing, and sometimes you need some math, like where are all my dots on the screen, and yes, you can use cosine and sine and all the different math things, but I mean, we already have all that. You have a rectangle in the scale mode and an angle. Why can't we derive a point from that? So yeah, we did that. So you have a G point from polar, where you pass in exactly what you had in the drawing routines. And if you, for example, want to draw an arc, and after that a few dots, or you want to combine it with a line, you can use the output of this function. And if you remember the one watch face that had red dots around the perimeter of a circle, if you want to have the rectangle that you then could pass into one of these drawing routines, use a G-rect centered from polar, which gives you a rectangle of a given size. Here I'm varying the size at an angle, and then you can use that rectangle for any follow-up call. For some of our layouts, we want to be flexible when it comes to distances. For that, we introduced a new G-rect inset, and it accepts a reference rectangle and a G-edge insets. And that's just a struct that has a top, right, bottom, and a left, and you are free to construct it. But we also have a convenience macro that creates that struct for you. And this macro actually has optional arguments. You can call it with 1 to up to 4 arguments, and it follows the CSS semantics. So if you just pass one value, you actually get a rectangle that's inset by 16 pixels in this example on each side. If you pass 2 arguments, the first one describes the vertical inset symmetrically on both sides, and the second one is horizontally. Third one is, top, and then the second argument is left, right. What people often overlook is that this also accepts negative numbers. So you can use this function also to expand your existing rectangle, maybe on one side, maybe on all sides. If you want to have it 5 pixels wider on each side, just say G-edge insets -5. And I think for these API calls, it's totally clear how you can implement stuff like that. So calculating these dots, easy. Use the full window, different angles here. You have a rectangle, use that again to say fill it. Or sectors like these, start and angle. And because they are our drawing routines following our semantics, you have anti-aliasing, fill color, and everything. Cool. So this is drawing. And then there are some changes about the UI. We have, for example, a change in the status bar height. The status bar height on a rectangular screen was always 16 pixel. On the round system, it is now 24 pixels. And if you remember, as we have the most text at the vertical center of the screen, we also want to center elements such as the menu layer. And to make that happen, we just give the menu layer the same amount of inset at the bottom. This 24 pixels and the fact that the status bar has its text at the very bottom of these 24 pixels looks a bit odd if you look at it here, but if you look at it at the actual device, it makes sense. Because of the geometry of the shape, it actually just falls at the right place. Now the code is also pretty easy. Please note that I never write anything like 24 or 132. We highly encourage people to do their layouts flexible and indirect by insets, for example. And in fact, I'm using this new inset function. I want to have the same inset at the top and at the bottom by the height of the status bar. So my first argument on that one here is just the status bar layer height. And the second one, well, I want to go full extend, is 0. And I use, to describe the frame of the menu layer, I just say, well, use the window bounds with these insets, and I'm done. Action bar also changed. The width is a bit larger or wider. It's from 30 pixels to 40 pixels. Also, it looks a bit odd on the isolated screen, but on a round display it makes perfectly sense. If you want to lay out your content according to that screen, you have the challenge to describe the rectangle here at the bottom left. And again, grec inset to the rescue. You just describe the insets by passing in the status bar layer height for the top, action bar width for the right, and 0, 0 for the other edges. And you use that based on the window bounds as your content rectangle. Easy as that. So for menu layer, you see here that we made a design decision. Because you can see the most at the center of the screen, we dedicate more space to the actual center. And we said that the selected element is always at the center. And to make that happen, the other cells must shrink. They are shorter than the centered cell. We call that center-focused element. And you see that throughout the system on the Pebble Time Round and various places. Whereas on the rectangular one, all the cells have an equal height. To make that happen, we introduced 4 new constants you can use, and they line up perfectly to the remaining space on the screen, so we highly encourage to use those. And you can still use the existing menu cell basic cell height for cases where you have a multi-column layout. In fact, if you look at your Pebble Time Round, I know not everybody has one yet, but you will see, for example, the alarms app does it when it's on and off. There we have a multi-column layout and we use the standard heights. Otherwise, use this mode where the focused one should be taller than the other one. And we do that by introducing for example here, menu cell round, focus tall cell height. And then you use the counterpart appropriate when it's not focused. How do we do that? As in our API, we just provide the height for the cell without knowing anything. Well, there's a new mode in menu layer where you can say, menu layer, please be center focused. And when your menu layer is center focused, you will be asked more often than we used to in the past about the height of a cell. And you have to make a decision. If the menu layer cell is currently selected, the one you're being asked for, then return tall, focused tall, and if I'm not selected, return the unfocused short. So you have full control over the height still, but we recommend to use these values. Here in comparison, or actually in the screen layout, how it lines up, and also next to that, how it looks on the rectangular screen. As you can see, all these API calls are actually the same across the displays, the different platforms. If you ever run into a situation where you need to decide to do something differently depending on the platform, for example, you want to use different colors or you want to use different resources such as images that are cropped out as a circle or something, you have 2 options. One is to use our defines. And you know, in the 3.6 days, we had this color fallback define, but it was always unclear what is the first argument for, what is the second for. So we generalized that now that we also have a shape to query for. You have a new set of defines where you say Pebble if rect, choose the first one, else use the other one. And we have the inverted one as well. So you can say if it's round, use that, and otherwise the other one. And you can do the similar effect with resources. When you describe images or fonts or whatever it is in your app info JSON, you can use the tilde suffix to say, please, on round, I want to have this one, or on rect, I want to have that one. And the question came up earlier today, if you want to have something that is rectangular but differently on black and white and on color, you can combine these tags. You can say, It is rect and black and white. Please use this file here. We highly encourage to query for capabilities, not for platform names. Technically, you could do an if-def Pebble platform applied, but then again, if you want to do something that's specifically for rect, you had to do if it's applied or without, and then if you want to do something for color, you have to say if it's without or chalk. Why make your life hard if you have these convenience macros? And also, it's more future-proof. Cool. So that sums up what I wanted to talk about. I'm here all night to answer any questions, yeah, that's about it. That I'm actually not sure. Do we have time for questions now? Okay, cool. Any questions? Yes?
So what happens if you don't update your app?
If you don't update your app, so as I said, this is the stripped down version of our presentation earlier. On 3.x, applications only run on the platform you compiled against. So on 3.x, once we have, for example, Applied 3.x also, you have to specifically compile for each platform. If you compile your app only for Applied, it will only run on Applied. If you compile it only for Basalt, it will only run on Basalt. And the same is true for Chalk. So short story is, if you don't recompile your app, it won't run on Pebble Time Round. That's it. Cool, thanks.
Thank you, Heiko. All right, next we have Nate Stockham from Stanford on the project Kraepelin. Is that how you say it?
Exactly.
Awesome. I'm going to talk about wearable psychiatry.
So I'm Nate Stockham, and I'm a PhD in neuroscience at the Stanford Bipolar Clinic, and PhD student. I'm getting ahead of myself. And I'm going to talk to you tonight about exactly what we're doing at Project Kraepelin. So actually how y'all can actually get involved if you're interested in it. So first of all, you might ask, why wearables in psychiatry? And you might also ask, what do wearables and health have to do with each other? Because we've had millions of devices out, wearables, Misfits, Fitbits, activity trackers explicitly, and no one in healthcare cares. Like, what doctor would use a Misfit or a Fitbit to make a diagnosis? When a blood test could do diabetes, heart disease, anything you want, much faster and 1,000 times better. So, what point do wearables have in healthcare? It's from like maybe like a general fitness perspective, but in order for a wearable to be relevant to a doctor, it has to provide a metric that can't otherwise be attained. It's a metric that would be unique to a system that can monitor a patient continuously in a way that a simple doctor's office visit could not. So at Project Kraepelin, we're developing that. We think we're developing the first time that you can actually make an argument to a doctor that they need to use a wearable for a patient. So before I dive into what Project Kraepelin is, let me give you a little bit of background on the disease and disorder we're trying to understand, better study, and better treat. Bipolar mood disorder. I don't know how many people here know the details of it, so let me give you a brief overview. It's a very heritable chronic disorder, which is characterized by three primary mood states, being depression, euthymia, or what most people would call normal, and mania. Now, depression is characterized by like sleeping a lot, it's like 12 to 16 hours a day, being very tired, sadness, grief. You get the idea. And euthymia is what most people consider a normal mood state. And mania is kind of the signature of bipolar. It's unique to bipolar, and it is a stage which is extraordinary in many respects. It can go on for months at a time. You can sleep less than 3 hours a night. You feel normal. You have extreme elevation of mood, and a whole variety of other symptoms. And to describe it further would be vastly oversimplified. But it's a fascinating disorder. But how is it relevant to you? So to give you a description of why you should care about this, let me give you some statistics about why this is the biggest healthcare crisis you've never heard of. So about 5% of people have it, some version of bipolar disorder. It's usually hidden. Most of the time it's hidden because of the extremely high stigma. Because when you see what is considered mania are just the word itself, maniac, portrayed in media as extremely negative portrayals. Of those 5%, about 25 to 50% will attempt suicide at some point, and if untreated, about 1 in 5, 1 in 10 will commit suicide. And what that translates to on a global-wide scale is that last year about 500,000 people died from bipolar suicide. In contrast, about 1.2 million died from AIDS. So about half people killed by AIDS are dying from bipolar disorder. What that means in terms of money lost to the patients that suffer from it in the U.S. economy is that bipolar costs the U.S. economy about $200 billion a year, at least in indirect costs. And using the same measures, cancer costs the United States about $150 billion a year, and diabetes costs the United States about $250 billion a year. So you can kind of see the magnitude of this healthcare problem. So again, what's the relevance? We have the main problem with bipolar disorder is that it's actually a very treatable disease. We have really powerful drugs that, if used correctly, can give someone their life back and make it a manageable, disorder. But the problem is it takes on average over 10 years to make correct diagnosis. You have an extremely devastating disease that's extraordinarily genetic. We don't have any genetic markers for it, and yet it takes 10 years to make an accurate diagnosis and get the correct treatment. So this is the primary problem in the current treatment and management of bipolar disorder in the United States. So how is Pebble relevant to this? At Project Kraepelin, we are trying to we're using Pebble to try to cut that diagnosis time down from 10 years to the first episode, the first few months. And the reason why this is significant is because the suicides that occur in bipolar disorder usually occur within the first 5 years. So if we can figure out if someone has this disorder or not, if we can control within the first few months, you're not only cutting down the risk of suicide by maybe 90%, but you're also providing them with a prognosis that is much improved. The earlier you intervene in the disorder, the less it costs, the better the prognosis is. So step 1 is diagnosis. Because if we had a way to continuously and objectively monitor a patient at risk for bipolar disorder in a way that's minimally invasive so they will comply with it, then you could catch this disease obviously. Because if you're sleeping 3 hours a night, like it's pretty obvious that you're an experienced mania. If you're sleeping 16 hours a day, that tells you you're in depression. This should be an easy disease to diagnose. There's no reason why it should take 10 years. And the reason why it takes 10 years to diagnose is because when in normal interactions with a psychiatrist, you only see one mood state at a time, because these last for months. If someone comes in depressed, the doctor sees the depression, unipolar depression, provides them antidepressants. Someone comes in psychotic, they see schizophrenia, they provide them antipsychotics, neither of which are actually useful for bipolar. But if you use Pebble as an activity tracker, as a way to continuously and minimally and basically monitor someone at risk from bipolar, you can catch the transitions between the stages, and you can catch if they have bipolar or some other mood disorder, differentially diagnose, and get them the correct treatment at much earlier stages. That's what we're doing right now in clinical trial at Stanford University in the Bipolar Center. And that's what we want to take, if it pans out like it's looking like it's starting to pan out, that's what we want to take to the larger psychiatric community. But this is only step 1, because it's a genetic and chronic disorder. You will have this for the rest of your life. And so the next stage is treatment. Is that we see Pebble not as just a monitoring tool, as a passive monitoring tool like you might have a Fitbit or a Misfit. But the reason why we chose Pebble is because you can reprogram it to actually get information and prompt information from the user. You can get simple things like self-mood ratings or sleep quality ratings. But if you can see someone's actually having starting to transition to depressive or manic episodes, you can actually prompt that someone for a voice sample, another way of objectively characterizing the disease. You can prompt that someone for a mood rating, or say, perhaps you should see a psychiatrist. It's a minimally invasive way of having a disease to be quantified that is otherwise mysterious and hidden. So while at the same time maintaining the privacy of the person that is using it. But this, we need help with. We have the monitoring system in place. We're using it in clinical trials. We're starting to get good data from it. But this is a much more complicated step. And this is why we want to use Pebble instead of these other activity tracker devices, because with Pebble and the developer community that Pebble has, you can actually start to build Pebble as an endpoint for an entire psychiatric management care system. that is where we see this ending up eventually, and that is why I'm talking to you tonight. As I want to know if, and I want to get your involvement in making this a reality, because you're not just talking about you're talking about someone's entire lifespan, that they're going to have to be dealing with changes in drugs, incipient manic depressive episodes. It never goes away entirely, but you can massively improve their quality of life with something as simple as just watching their sleep patterns. And it's and having some way for the doctor, the treating psychiatrist, to see through time how the disease develops and how to best intervene. So if you want to get involved, I'll be here all night. I want to talk to you. I'd love to talk about it more. I could talk about it for hours, obviously, but it's using Pebble as a psychiatric care device in a way that allows us for the first time to objectively characterize a disease that otherwise has just been described subjectively is what we are doing at Project Kraepelin at the Stanford Bipolar Clinic. If anyone has questions, please let me know.
What are the main data inputs that you use to tell if a manic state or depressive state is coming up? And two, what are the actual circle of care intervention alerts do you look at?
Excellent
a lot
question.
of times, I worked 8 years as a counselor along with being a developer, level 13 SOs, 187s, and dealt with a lot of manic depressive issues.
Right.
So, what are the things, the main data endpoints you need in, and what are the data alerts, and what are the alerting to maybe the circle people who can kind of intervene?
Excellent question. I'll take the first part of that and move on to the second. First part is what kind of data points we use. So right now we're doing three, or four. We're doing the raw actigraphy and imputing from that energy output, actigraphy, motion sensing, using that to impute raw energy output and sleep patterns. Two, we're taking daily mood ratings, simple, but something we haven't been able to do before. And three and four is sleep duration, sleep quality. So over time, the idea is that you can you begin to see the transition in sleep duration and energy output, and catch that even as it's occurring in real time. So that's the kind of data input that we would be looking at. Something simple, something that the patient has no problem with complying with, something that is that no one would know what's going on. Something that can be extremely private to the patient because there's obviously a stigma around it. As for the circle of care, you obviously want to have a treating psychiatrist involved, but you want to make sure the patient doesn't feel like they're being watched. There's a very thin line here between giving someone the freedom to live their life as they want, but also acknowledging that it's a dangerous disorder. So in terms of management of care, you want to have you would ideally have a system that is accurate enough in predicting oncoming depressive and manic episodes that would only alert the patient or only alert the doctor when there's a higher than some probability chance of self-harm or some other major life disturbance. So there would be some algorithmic mediation in the process of care. As for when the psychiatrist be involved, at that point, the psychiatrist perhaps prompt the patient without any other intermediaries for, let's say, how are you feeling today? Could you give me a brief voice recording, just see how your pitch and tone is? And then, if there is if the psychiatrist believes that there's a major problem, then maybe instantiate a phone call. But again, keeping it as tightly private and between the treating physician and the patient alone, involving no other parties. Any other questions? Questions?
So how do you deal with it?
That's an excellent question, and obviously one that's we've been having to deal a lot with in terms of the internal review board. What information is going to be collected? Because the more detailed information you collect, obviously the more protections to be in place. For example, we're not doing voice, and probably won't do voice for the foreseeable future due to HIPAA compliance problems, and we haven't been clear with that yet. But that is one avenue in the future we could explore. Now, there are ways you could de-identify that data using voice analysis on the device that would make it even less person identifiable. There's a group in Michigan actually doing this very same thing. They're being much more invasive. They're recording entire conversations. We were just doing snippets, but they're doing all the processing on the phone and de-identifying it and then sending it to the server. So they got around HIPAA using that. But so there are some things you can do that allow you to not deal with the full weight of HIPAA, but you still have to know that you're dealing with someone's private information. Other questions? Question.
I would like to ask how are you dealing with the battery life in the device? Because I was working on a project for bipolar patients also, which employed like custom-made bracelet for activity tracking, actigraphy basically, which would last like something like months before there was a need for a charge. So is there some routine that machines has to do to charge a device?
That's an excellent question, and that's one of the reasons why we picked Pebble, actually, is because of long battery life. Is obviously an infinite battery life would be ideal, and a specialized tracker like that might be useful for certain patients, but having the reprogrammability is one of the major features of Pebble that we needed, and the long battery life as well. So it's so insofar as like scheduling for that, we haven't. Right now, we're trusting the patients to do it, but we would love to build logic in that would like prompt the patient, like help them establish a charting schedule, anticipate when we're going to be missing data from the patient. But we haven't been able to, obviously it's a complicated problem, so we haven't been able to like build it in yet. But that's some problem that we've definitely been considering.
And actually, could you say what is your battery life? You do like whole day actigraphy on it? Because I have an app which does sleep tracking. It's something like 8 hours of actigraphy. And it lasts on Pebble, which is incredible. No other wearable has this. It lasts for something like 5 days, tracking each night. So my question is, how long does it last when you do like permanent actigraphy, like all day long?
All the same. I mean, a great thing about accelerometers, I actually thought about building my own device before I decided to use Pebble. Is the great thing about accelerometers, they use nanoamps. So it has virtually no effect on battery life. So we get the full 7 days of Pebble battery life. Any other questions? That's it. Thank you all so much.
So today I would like to share with you one of the seed new product this year, and also show you guys how this product works with Pebble. So this product is called WePhone. It is the world's first open source modular phone kit that allows you to easily create your own mobile phones. So mobile phone used to be very different and constantly evolving, and nowadays it all looks like this. So C believes that mobile phone don't have to look like this. So we're thinking about, is that possible to find a new way to communicate with things? And is it possible to find a new way to make different kind of stuff to become mobile phones? So that's why we make WePhone. And here's a video that may help you understand more about this product.
This is WePhone, the world's first open source modular phone kit that allows you to easily create your own mobile phone.
With WePhone, you can also enchant things with cellular connectivity.
Remember, mobile phones used to be very different and are constantly evolving. Nowadays, the bulky rectangular touchscreen phones all look the same. What we need is another renaissance. What if we redesign the phone to be anything we want it to be? For the past 8 years in Shenzhen, Seed Studio has been busy hacking the electronic supply chain to make advanced tools and technologies available to everyone. The result is the WePhone. The heart of the WePhone is a GSM module, featuring the world's smallest computer on a chip that easily fits to anything. Give your WePhone life by adding a touchscreen, audio, GPS, NFC, motion sensor, camera, a single eye display, and many other cool modules. Just plug modules together using flexible NFC strips. Once connected, you can send texts and make calls, and even program your own logic. Update your settings with a simple text, and a full-power SDK, BLA, and JavaScript are ready for developers. Next, give your WePhone a body by using the pre-cut craft paper. Play with different design patterns to make a phone unique to you. Or consider leather, bamboo, fabric, or existing objects, even create a sturdy case using 3D printing, laser cutting, CNC, or injection molding. Imagine making a call to your dog by adding a GSM and GPS module to the dog collar.
Peter, come back home now.
Program your WePhone with if this then that logic so your dog never gets lost. Or add gyros and GSM modules to a kite and talk to the sky. Or send messages to control your robots remotely. Talk to a door, desk, bike, or tree. We partnered with incredible people, organizations, and companies around the world to bring the WePhone to you.
We're proud to bring reform to the world, and excited to see what you will combines. Please join us by backing this project, and let's begin the renaissance of phones.
Make your call.
Yeah, so this is the call modules of Refone. So basically, this module we call it GSM and BLE. So it includes 3 different kinds of protocols: GSM, GPRS, and BLE. So it's so small and light in weight. So it's for example, if I sew it on my shirt, and then my shirt will turn into a phone. So, but I know that one module is not enough. And then, so that's why we make the Refone family. You may need different kinds of modules to expand the various functionality. So you may need the touchscreen, LED or NFC and GPS, something like that. And most importantly, this module is compatible with Pebble. We did a survey before and to check what kind of function that Pebblers would want to add on Pebbles. And then the GPS function and the NFC function ran in the top 2. So that's why we make this adapter, the first one, and also we make the Xadow GPS and Xadow NFC. And then we put all of these modules together and make it as a kit called Refone Strap Kit for Pebble. Here are some pictures to show how this kit works with Pebble. So this is the adapter. You can see the 4-pin there, and this 4-pin can connect the Pebble down magnetically. And then this is the picture to show you how it looks like after this adapter connect the Pebble time. And these are the 2 cables that can connect the NFC modules and the GPS modules. And it is how it looks like after it gets dressed. So here are the 2 real things. I will show you 2 demos about this. And maybe let's first to check if my phone works well.
Please.
There it goes. Okay, perfect. Like program it with IFTTT right now. So I will set this. Here has a button. So I will set. If I press this button, it will call you and send you a message. Yes.
Can we press the button later? Everyone press the button.
Yeah, I can send you guys this demo later. And also send you a message.
Not see it.
Am I on the camera?
Yeah. Sorry. Okay, done. So I press the button here, and the signature gas. And you should also have received a message, right? You should.
Come on, bro.
Yeah, Pebble is amazing.
Yeah, so this is the message. Pebble is amazing. Thank you. And also, here's another demo for the Pebble strap. So we connect the NFC modules and the GPS modules. And we made an app for Pebble, and the app's here. And it's connecting. Okay, I think I got a picture of that to show you the result. It should work. It should work. Anyway, it's here. So actually, you will get the message from your Pebble to tell you what's your latitude, longitude, velocity, altitude, or such information. And also, if you use the NFC modules, it can read the ID of the device. Yeah, so that's it. And I'm going to put it here and to see if it works in the end. Yeah, so that's it. So if you like this product, please welcome to join us on Kickstarter. Or if you have any ideas of this reform, please share your idea on this website, and you may get a reform create kit. And also, the last but not least, if you think there's any potential cooperation between you and C, just let me know and drop me an email here. Here's my email address. And Pebble Time Round is amazing, so I should get one. So that's it. And oh no! And also, I think C should make the wrong adapter for the Pebble runtime, right? Yeah. So that's it. Thank you very much.
But as Kat mentioned, Pebble Time, as you guys probably know, has 64 colors natively. With the help of something called dithering, you can actually add what looks like much more than that. 343 sort of cleanly, and if you start to get a little bit fuzzier, if you assume your users have maybe worse vision, you can get to much higher than that. So I don't have any slides, but I figured the easiest way to talk about the Simple Dithering Library would be to show it to you. So let's visual presentations look much better when you can actually see what's going on. So I'm going to start with some very basic stuff, just because this is a new concept to some people, and if it's not new to all of you, I apologize. But what is dithering? So dithering is basically using lots of dots to make it seem like there is a presence of a color or a shade or tone that you otherwise would not be able to get. So as we saw this morning for some of us, that's very common in older comic books, sort of very pop art type of look. You also see it in other circumstances where you might have limited colors available, or printing, for example. If you take a really close look at most newspapers, you'll see that all of the images they have in sort of what looks like grayscale, it's actually just a lot of really fine black dots in varying densities to give the illusion of shade. So, in order to bring that capability to Pebble Time, I wrote the very basics of the Simple Dithering Library. It's been added to by a couple of people. It's a great sort of ongoing open source project. I love seeing the new stuff people are adding. So I'll just jump into sort of how it works. So this is a Pebble Time, currently displaying a big black square. But let's say that we want to add a bit more color to this. So let's say we want to have kind of a basic checkerboard pattern. That's great. Black and white, two colors everyone's very familiar with, especially if you have an original Pebble or Pebble Steel. But this doesn't really do much. This isn't adding like a new texture or a new shade or anything special. So what happens if we make it a little bit smaller? So, okay, cool. You're all still able to see that is a bunch of black and white squares and not anything magical or special. So we'll go a little smaller. Chances are this still looks like a bunch of black and white squares to you guys. But if we take it to the extreme and we make it really tiny, such that we're looking at a pixel level, this looks gray. And it looks like 50% gray, which is a color not actually available on Pebble Time or any of its variants. And so the way this is done, basically, so this is drawn at what the library calls 50% dithering. which is an even mix of both colors, literally just alternated pixel by pixel. So on sort of a bigger scale, as we saw with the previous images, the human brain's really good at seeing patterns when they're big and they're visible. But when you take those patterns down beyond sort of the resolution of the eye, it just kind of blurs together. Unless you have, incredibly good vision, chances are you will look at this and sort of see it'll all blur together. And your brain does this just because it makes sense, it's easier. There was no evolutionary advantage in being able to see individual pixel by pixel. Maybe someday there will be, but not today, fortunately for me. So this is a 50% dither of black and white alternating pixels. But we can also do other combinations. So if I wanted to get 25% white, 75% black, you end up with sort of a darker gray, 75% gray. If we go the other direction, you get lighter gray, so 25% black, 75% white. Now, you can't really see it, maybe you can on the camera, but at these shades, the dithering is a little bit more visible. That's why I tend to stick with the 343 number, so that number assumes that you only do 50% dithering with all of the available colors. Another interesting thing to look at, so the first 50% I showed you was straight black and white. However, Pebble Time has light gray and dark gray. So if you actually take the average of those two colors, you get a much more uniform gray. The difference between individual pixels is even less noticeable. And when I wrote this, I actually had to go back and make sure that I had written the correct code, because this just looked like light gray or dark gray, and I could not tell the difference. So that's sort of how you get pure gray on a platform that only supports 33% gray and 66% gray. But like I said, we can do other shades too, which may be not useful for such a large area as the square, but if you take it to the next level, you can sort of have nice gradients. And in this case, we have 25% jumps from pure white to 25% to 50% to 75% to full black. However, we can break it down into even more discrete jumps. So this is with 10% jumps. Basically going from white to 10, 20, 30, 40, 50, all the way up to full black. And this looks good. It could look a little better. Obviously, you're looking at a camera that is highly zoomed in on this, so you're going to see all of the fine details. But thanks to a contribution to the library by Morris Tim, we actually can take the two extreme colors, black and white. We know that there's light gray and dark gray in between those, and thanks to his contribution, so does the Pebble Simple Dithering Library. So as you can see, this is a much more fluid transition because it's actually going not all the way from white to black, but from white to light gray to dark gray to black. And so it fits incremental shades in between that. You can also do transitions. So this is sort of transitioning a nice sort of fade effect from white to black and back again. Just using a simple timer and just incrementing the dithering percentage by 10% each time. One other thing that I added a little while ago, which is sort of really hard to see actually with this lighting, but that's a gray circle. You'll have to take my word for it. One of the advantages to the way that the dithering library is done is it uses absolute pixel positions to determine whether or not a pixel should be black or white or one of two colors, which means you don't get a flickering effect if you animate your rectangle or circle or whatever across the screen. Additionally, there's one more effect that I didn't have time to include in this demo app, which is dithered text. So thanks to Yuri, you can now draw perfectly dithered text. So if any of these colors seem really appealing to you, you think that looks great, I'd love it as a rectangle, I want to draw text in that, you can now do that with the Simple Dithering Library as well. And so that brings me to the end of this little demo app. But I want to highlight how much this has already grown sort of further and more expansively than I could have imagined when I started it. So I thought, hey, wouldn't it be cool if spent a lot of time zooming in far too much in Photoshop on the paint bucket tool and what that was doing, and came up with the basic concept, which people have added to. Animations have been added, the text I mentioned, the sort of smooth gradient. All these were stuff that people have added, and this is a great open source project. If you think you have something to contribute, pull requests are always welcome. You know, I find people using this in random apps, stuff that I wouldn't have imagined for, and it's really great to sort of see it continue to evolve as people come up with new uses for it. The last thing I will show is an app called Swatch, which is upside down, but that doesn't actually matter, which is in the App Store now. Heiko's going to do some magic. And also just actually, oh wow, magic. So this is an app in the App Store now, and what it does is basically lets you set any RGB value and then draws the corresponding appropriately dithered mix of colors to get that value that you were talking about. So as we're going up, you can see it's going from black, starting to become dark blue. Once we get past 85, it'll go from dark blue to a little bit lighter blue. And doing this, we can sort of go all the way across the full color spectrum, basically. And so it's just a fun little app. I encourage you to kind of check it out, see if the dithering library is something that appeals to you or could be useful. And this is how you end up with at least 343, and possibly for your more nearsighted users, more colors on your Pebble Time. Thank you very much. Are there any questions? I'm happy to chat more now or wander around. Yeah.
So, has anybody done anything to convert like a PNG that you downloaded over the internet? I've been doing it right now, and obviously I'm just picking the 64 colors that are available. It'd be nice if we had a tool to convert them, ideally in JavaScript, into digital images.
Yeah, so that's sort of the next step that I'm hoping for this library. There's a great example of converting colors from the internet into 64 colors with, oh god, I'm blanking on the name, Ghost Camera, the Instagram Ben Combe's app. Phantom Camera. It has a great open source JavaScript example of how to do that. I'm hoping to sort of merge that with the dithering library and see if there's an easy and clean looking way to do a bit of both.
Can I jump into that?
Yeah.
Matt Hangerford actually did that. Who asked the question? And where's
I asked it.
Okay, so Matt Hangerford did that to actually transfer local photos from his Android phone, did it on JavaScript, transmitted them a PNG that uses the support and displayed it on the Pebble. If you find him, Matt, are you still here?
I think he's over
Okay.
in the front desk.
Okay, cool. So talk to Matt. He did it.
Any other questions?
Any other questions? All right, sounds good. Thank you, Matthew.
Thank you.
Awesome. All right, Dan, what are you going to show us?
Okay. So, let's see. Here is the watch face that you might have heard of, Time Style, which lives on page 2 of the most hearted watch faces. But anyway, so the thing about it is we've got this little weather thing, this little date thing, and oh, isn't that great? But what if you don't like the weather, and what if you hate calendars? Well, now you can solve that problem. So in the latest version, we have this thing where if you awkwardly focus this on the phone screen, oh, look at that. So this is what the configuration, or at least a fraction of it, looks like. And so if we scroll down and give you all vertigo here, we can see this new thing where you can select from all these different complications. So what if you don't want the current weather? What if you want, oh, I don't know, today's forecast? And what if you want, I don't know, pick one.
Battery.
Somebody wants the battery? Okay. And we had a vote for seconds, I heard. So let's switch to seconds here. Okay, and so now we can hit send, and theoretically, if we go back to here, it will now have all of those things looking just like it did on the thing. So, wow, that was amazing. So that's basically it for that. So the real key there is I really like configuration pages that show real-time previews. The next time you write a configuration page, I think it should have a real-time preview. And all of this is open source, too. And it's MIT licensed, so you can steal it without crediting me. So that's important. So you can find it on GitHub at freakified.github.io something. Okay.
It's in the spreadsheet, right?
It could be in the spreadsheet. Okay.
It should be in the spreadsheet, so you can look at it later. Thank you, Dan. Uh-huh. All right, Stephen, all the way from Australia.
Hey, so I like playing with timeline apps. I wrote a multiplayer one a little while ago called Timeline Tag, but it's a bit slow, and you're going to have to go looking for tags. So I came up with a new idea called Poke, where you have a start a two-player game with someone else, and then you poke a pin between the players. Each time you poke it, the pin gets further and further into the future, and the idea is you push it into the future before it goes into the past. And as you go along, the more you push it, the less it goes forward by. So at the start, you'll go forward by 100 minutes, and then it'll eventually go down by 5 minutes. So, if it's almost expiring, you've got 5 minutes left, good luck. And so there should be a pin arriving shortly at some point. Here's one I prepared earlier. 7 minutes, here's one, Stephen poked you. So, looking here, we've got pokes. This is a brand new pin, no pokes, nothing there. And then I can poke Stephen. So, here we have HTTP actions doing their thing. They're awesome, by the way. And that'll disappear shortly. And if my time runs out before the pin arrives, hopefully a pin will arrive. And, whenever the server figures it out, because timeline isn't exactly right. Anyway, so yeah, it's on the App Store now. It works on Basalt and Talk, works on all times. And that pin's gone. It's been killed. There should be another pin at some point soon. Yeah. Anyway, so, yeah, that's it. It's in the App Store. It's called Poke. ! Have a look.
Thanks, Dan.
Hi everybody, my name's Damien Bears. I created the Evernote for Pebble. And if I was sensible, what I'd be showing you now is voice notes on Evernote, which I got working today. But oh no, I'm going to try and show you something completely different, which may or may not work with a shaky camera, shaky hands, and so on. But we'll give it a go. Thank you. I'm going to talk without this, if that's okay.
Okay.
Okay, so like a lot of you, I'm kind of... Sorry? Oh, thanks. Like a lot of you, I'm not only interested in wearables, but a lot of other stuff as well. And if you're around in the 1980s and VR was around then, you were bitterly disappointed by what happened. And it's getting exciting again. It's getting really exciting. And things like Google Cardboard, for me, are an easy, simple way of getting into VR. So let's see if you're going to be able to see anything at all. Unfortunately, it needs to be held up. So I can try that. Wow. Fabulous. Yeah. So what you're seeing here is a little bit of an experiment I've been doing, exposing a kind of virtual library inside. There we go, demo effect. So one of the weird things about VR, when you put this on and you're in it, is the first thing that everybody does is go like that, and they can't see anything, of course, because their real hand is not there. But I thought, why not bring your hand into VR? And I'm going to ask for an assistant, thank you very much. Okay, so how can you do that? Well, the Pebble has motion sensors in it. It's got a compass in it. So why not automatically, and we'll see if this works now, why not bring my hand?
What are you going to show this time?
So this time I'm going to show an app I've been working on called Vox Populi, which means voice of the people, because I'm a Latin nerd. I'm going to have to ask for total silence. Reasons that will become apparent momentarily.
Nope. Nope. I just said. Sorry.
There we go. This is day and night too, by the way. Shameless plug. So one of the things that I was most excited about with the new voice API is translations. So I'm going to do a very quick, simple demo of this to show off the new dictation API. So I speak English, and let's say I'm in Italy and I have had too much to drink, and I really, really, really need to find a bathroom. So silence.
Where is the bathroom?
Dove è la bagno, ladies and gentlemen?
What are you going to show us?
The future of Smartwatch Pro, which is voice control.
Sounds exciting. Let's see it. Did you guys just get access to the voice API today? Wow. Okay, so all these voice related things happened in like 4 hours today. Okay, maybe 6. Like 6.
I cheated a little bit.
Okay, well, all right. Truth comes out.
So this is my app. What it does is it brings like some popular phone apps to your watch, like your calendar. And so I've been using the new dictation APIs to do some cool things. So let's see. So right now you can do 2 things, which is play music. So you can control the music app on your iPhone, and you can post tweets and reply to tweets. Let's go back. Tweet, hi from the Pebble Meetup, hashtag PDR15.
Let's see what it does.
That's actually just the system dialog. Let's submit this and see how it goes. So right now it's loading the Twitter timeline, and here we go. It correctly handled the hashtag. So now, if I go into this tweet, I can, of course, retweet and favorite, or I can reply to myself. Nice to meet you. There you go. So now, let's look at music. Play Good Life. As you could see, it launched the music app on the Pebble. And now everyone's favorite song. Play Everything is Awesome after this song. Try again. Play Everything is Awesome after this song. One more try. Play Everything is Awesome after this song. There we go. And so now that song has been queued and it plays after this song. So you can ask to play an artist, ask to play an album, songs, playlists, and play them shuffled or play them after the currently playing song. So I'm planning to increase the functionality and integrate with calendar and stuff. So that's just the beginning. Thank you.
Thanks, Max.
Hello, I'm Edwin Finch, and some of you may know me from my Kickstarter campaign, which is Lignite. Yep. Thank you. We launched our Kickstarter campaign in March, Philip and I. He was actually here from Switzerland. We met online about a year ago. I never met him in person until last night, which is a pretty freaking awesome experience. And so anyway, our Kickstarter campaign was based around creating a beautiful set of watch faces and watch apps for Pebble, Pebble Time, and now Pebble Time Round. So we've got companion apps for iOS and Android.
Just put it as it was.
Sure. Sure. So I'll just swipe through a few of our designs here. So basically, Philip is the designer of everything that we make, the iOS app, the Android app. I can't design for my life. If I could, I wouldn't be a developer. That's why we work so well together. So here's personal. It greets you. It says hi friend right here, but you can customize it to say your name, a friend's name, whatever. Here's beat. It shows not your heartbeat, unfortunately, but you can make it have this really cool animation where it shows a heartbeat animation every second. Unfortunately, I'm wearing my Pebble Time Round, so I can't show you these designs because we haven't ported them yet. Yeah. We're going to be porting everything that will look good on the round very soon. Here's equalizer. This is pretty cool. It does have an equalizer sort of animation. It rolls through the different bars, and you can customize it to show the amount of minutes, which is actually the initial feature. You can customize it to show battery life, Bluetooth, etc. And I just wanted to give a shout out to the Pebble community. I've been here last year in San Francisco. Some of you may not know I'm still in high school. So meeting everyone here and just being in this room is life-changing. And I just want to thank you all.
Thank you, Edwin.
Okay, so if anybody's ever browsed the Pebble App Store, it has lots of black and white apps, and if you have a color Pebble, this kind of sucks because there's still black and white on your color Pebble. It just, doesn't magically make them color, shockingly. So I wrote a which orientation is this camera? Oh, except you can't actually see. Okay, so
just put it the normal way and cover it with the rest. One more.
I can just open this up on the desktop computer. It is a website. So my phone. Anyway, so you can pick any Pebble app. So what's a Pebble app that's black and white? Anything. I'm going to use Misfit. Misfit. So you can say, just type in app, select it, and Misfit is black and white, but maybe I want to make it, gold or something, gold and black. So you just select your colors, hit the button here, and I have to scan this on my phone. So a test of whether this actually works live. And then Pebble going here. It also does, I have to alt tab back. So here's another thing I was working on was upside down weather. So this is a new feature. It's not available yet, but you can put weather on any watch face. But it'll just load in the one that we just made with the new color scheme. Please work. There we go. And there's our recolored watch face. So this works for trust me, it's gold. There we go. It's gold. Yeah. So any app in the App Store. You can swap colors now, flip the screen upside down. Soon you'll be able to add weather, as I was showing before there. So you can add weather to any watch face. Bluetooth disconnects, works for anything in the store. So magic.
Sandy magic. Yeah. Sand.cpfx.
Just Google remix Pebble apps.
All right, I'll just do that.
Magic search term.
Yay. All right.
So a couple of weeks ago, I went to Hack the North,
And on the bus ride there, I was bored, so I needed an idea. So my idea was App Store. The Pebble App Store on the Pebble. So I'll just open it up here. Now it's built using Pebble.js, so it requires a phone connection at all points, but that's required anyways because we're installing apps. So in my demo here, I'll install a watch face. Or actually, you know what? I'll install one of the apps from today. So basically, all of these are the categories and collections. You can browse through various categories. Everything that the Pebble App Store would have is also in here. So let me just go back and head up to all apps. And as you can see, there's Poke, which was published today by one of the developers at the retreat. And if I head in, you can see there's an info option, which tells you some information about the app. I also have a version that has images, but it's not fully working yet, so that's to come hopefully. But the coolest feature, I think, is the install feature. Now, the problem with the install feature is it makes use of the developer connection. So, on your phone, I don't know if you can see this, you have to go to the developer mode, and you have to be connected to the Wi-Fi so you have an IP address. This way it's able to push the app to your phone. And basically from there, you just go, select install, and then it requests the Pebble app from the server, and then installs it on your phone. And now I have Poke installed. And then it also does watch faces. So if I go here, and then, I don't know this one, but install, and it does the exact same process. And you'll see with the watch face, it'll actually set it as the active watch face. And there's the new app installed. Thank you.
Thank you, Matthew. This is Peter. He came from the Czech Republic to show you cool stuff.
Hello, guys. I don't know if you know, but we are at the beginning of a new era. And this is the era of smart health assistants, which will use all these great data we have from life expectancy studies and advise us on how to live better. So I was thinking how I could use Pebble and 5 hours on our current today's hackathon to put together a health assistant which would do nothing less than improve everybody's health and lifespan, right? So I invented fit stickers. I don't know if it's the right name, but basically the idea is it's a watch face. It's optimized for Pebble Round. Actually uses another Pebble example project, I think dots and something, I forgot. Anyway, but what it does, it shows you a sticker on your watch face, advising you what to do. So now it's my beer time, obviously. But anyway, you can configure it through the configuration page, and you could put very, very interesting use cases. For example, water intake is a big issue. So you could put regularly during the day water sticker on your watch face. It will wipe a little bit, and you know you have to take your regular water. Of course, lunch, dinner. For example, if you forget about your lunch, you eat too much for dinner in the evening and you get fat, right? So this is what we don't want. There are many, many more use cases. For example, popular one, sexologists. How do you pronounce it? Sexologists?
Psychologists?
No, sexologists. Sexual intercourse. Okay, forget it, guys. Doctors who think about sex, right? They say that in the first year of your relationship, you are having more sexual intercourse than for the rest of your relationship, right? So it's a very good idea to put a sex reminder on your watch face. And the cool thing about this is you don't need to tell your girlfriend or wife. You just do something like... Thank you.
Thanks, Peter.
I'm working on, when I first saw the Pebble Time Round, I thought, I want to try to make this look almost exactly like many luxury watches that people have out there. So I made 2 simple watch faces. This one, don't know if you can see it very well. It, like other watch faces, they have the 3 dials down here, the left one being the day of the month, the middle one being the day of the week, and now knowing that Pebble's a smartwatch, you can actually get weather. So the right one here is the temperature in Fahrenheit. And then in addition to this one, the other face that I have, kind of along the same lines, except everything is a little bit more explicit. You can see here Thursday, I'll move in a little bit. Thursday, the 8th, and over on the left you can see it's 71 degrees, and even though it doesn't look like anything, I think it's a weather icon over to the left. I think it might mean haze or fog. Oh, right there. San Francisco, so it's probably fog. But pretty much it'll update and there'll be a little weather icon there. And I'm working on adding more, so if anyone has any suggestions, please find me tomorrow or any of the other days and let me know what more watch faces I should make. So, thanks.
Thanks, Chris. Chris also has a really cool transit app called Get Me There. It's in how many cities now? How many cities is it in now?
15 in the US and 3 in Canada.
15 in the US and 3 in Canada. All right. So this is going to conclude our lovely meetup unless anybody else wants to do another meetup. Or so, rest in peace. Okay. So we do this every month. For those of you that live here in San Francisco, we'll have another one in November. For those of you that are abroad, again, if you want to start something like this in your area, please let me know. We'd love to support you and maybe even send a Pebbler out there to hang out with you in your hometown. So thank you all so much for coming. We really appreciate you all being out here. We have more beer. Please drink it. And we'll see you next time. Thanks.